So isotopes, when we talk about a given element, there are different isotopes of that element. Almost every element in existence has different naturally occurring isotopes. And so when we talk about an isotope of an element, if we're talking about the same element, what has to be the same about those two isotopes? The number of protons, right? Because what do protons do?
Define the element.
They define or identify the element. But the number of neutrons can be different. And when we have isotopes of the same element, they'll have the same number of protons, but different number of neutrons. So if the number of neutrons changes, what else changes? Does the charge change? No, neutrons don't have a charge. But what will change? The mass. So isotopes of a given element have different number of neutrons and different masses. So let's take carbon, for example. There are 3 naturally occurring isotopes of carbon. Okay? We've got carbon with 6 neutrons, carbon with 7 neutrons, and carbon with 8 neutrons. All 3 of these isotopes are carbon. So what's the same for all of them? Protons. All have how many protons? 6. So when we are representing atoms, isotopes, there's really 2 primary ways we can write to represent it. One is with a nuclear symbol. So what I want you guys to do is take a minute. For each of these 3 isotopes of carbon, we'll write their nuclear symbol. What? I didn't hear what you said. Okay, so for the first one, what is the nuclear symbol? What do I put in the middle? C, because that's the symbol for carbon. What goes at the top left?
Mass.
Mass, which for this isotope is going to be what? 12. And what goes at the bottom left? 6, the atomic number of protons. And if the particle had a charge, which we don't have any reason to think it does, we'd put the charge at the top right. And we can also write this, another way to represent this ion or this isotope is by writing the element name, so carbon dash. And what is that 12? The mass. We will in the next unit when we talk about periodic table. What about the nuclear symbol for carbon 13? See, it's the same. Very good. And then we could also write it as carbon dash 13. And what about the last one? And then carbon dash 14. Very good. If you don't have it out already, will you guys go ahead and get your periodic table that you got last class? You got a periodic table last class? Yes. Okay, so find carbon on your periodic table. So it's got atomic number 6, right? And it's got its symbol. What about this 12.01 at the bottom? That's the what? That's the average atomic mass. So let's go back to what we were looking at. Pardon? No. I would, and the directions for it. It's not. So the average atomic mass is 0.1. They don't tell you the unit. Well, there are 3 isotopes of carbon. One has a mass of 12, one has a mass of 13, one has a mass of 14. How is the average of those 12.01? Well, if we did 12 plus 13 plus 14 divided by 3, what would we get?
12 plus
13. You would get 13.
Oh.
Right?
I don't know.
Yes.
Wait, 12 plus 13.
Plus 14 divided by 3.
That's 26.
It's 13.
39 divided by 3 is 13. Yes. It's 13. It's
Well-
probably something to do with which one is more like occurring.
That's it exactly. That's it exactly. So when we look at the average atomic mass, and we're going to spend a lot of time talking about it, it's not just an average, like there's a name for it and it's escaping my mind. The type where you just add them all together and divide by how many you have. Mean. It's a weighted average. So if the average atomic mass of carbon is 12.01, which of the 3 isotopes do you think is the most abundant? Carbon 12. Very good. Very good. The last part for this isotopes is just representing isotopes. So, like I said, we can write the element name dash the mass number or the nuclear symbol. So you've got 2 isotopes of chlorine. If you'll write both of the ways to represent those and tell me which one is more abundant. $35.45. Where did you figure that out? Good. So found chlorine on the periodic table, and its average atomic mass is 35.45. If we look at the 2 isotopes of chlorine, we've got chlorine 35 and chlorine 37. So which of those 2 is more abundant?
35.
Chlorine 35. How did you decide that?
Because you rounded it down.
If you take the mean, it's 36 and 35.
Good. The average is closer to 35. Very good.